Okay, so we're continuing from lesson 1-4 notes. We have a lot of definitions. Those definitions we have in previous notes, but there's two that I want you to add to your notes today, and those are collinear points and coplanar points. So for collinear points, those are points that lie on the same line, and coplanar points are points that lie on the same plane. So put those two in your notes. On a plane, now plane we're talking about like a flat surface, like your tabletop is now a plane, the floor could be a plane, the wall could be a plane, a piece of paper could be a plane. So that's something new that we haven't had before. Let's now talk about a few postulates before we go over anything else. Please put the definition of an intersection in your notes. So this bold, the intersection, that sentence needs to go in your notes. The intersection of figures is the set of points the figures have in common. Okay, so we're going to talk about those four postulates quickly. So postulate number 1 says through any 2 points there is exactly one line. Okay, so we could draw a point, and through that point we could draw infinitely many lines, correct? So one point does not determine a specific line. It could determine infinitely many lines. So postulate 1-1 says that through any 2 points there's exactly one line. So if we were to draw 2 points, there is only one line that will go through those 2 points. And hopefully I will be able to draw that. Okay, so that's the definition. That's what postulate 1-1 says. Through any 2 points, there's exactly one line. We can only write or draw one line. That's why when we name a line, we use 2 points, because that tells us specifically which line we're talking about. Postulate 1-2, says if 2 distinct lines intersect, then they intersect in exactly 1 point. So the term distinct means 2 different lines. So if I have this line and I draw this line and they intersect, they're only going to intersect in 1 point. So that's what that postulate says. 2 distinct lines, if they intersect, they will intersect in exactly one point. When might 2 lines not intersect? Yes. When they're parallel, yep. So in that case, there's no intersection. But here it says if the 2 lines do intersect, then they will intersect in 1 point, as long as they are 2 separate lines. Postulate 1-3, if 2 distinct planes intersect, they intersect in exactly 1 line. I'm going to skip that for just a second. Postulate 1-4, through any 3 non-collinear points, there's exactly 1 plane. So Jacob was talking about that when he drew the problem. We can't have, there we go. There's a point. If I drew those 2 points, I could draw a line through it. I can't put another point on that line to identify a plane. So those 3 points not being on the same line tell me I'm talking about a plane. Okay? If they were all on the same line, really all I'd be talking about would be a line. So they have to be non-collinear. They cannot be on the same line in order for us to be talking about identifying a plane. Okay, so I've got to give you a visual that I can't put on the recording of the 2 planes intersecting, but think of it as 2 pieces of paper intersecting, how that would look. Okay, so first of all, make sure you put today's date on that sheet of paper that has these problems on there. And then we're going to talk about A, B, and C. So for figure A, we're looking at what line is drawn. Okay, so how would we identify? We have 1 line drawn. We could draw a bunch of lines, correct? But they have drawn 1 line for us, and we want to identify that. And remember, to name a line, we either use 2 letters on the line or a letter that's outside of the line. That's usually in cursive. We don't have that letter, that single letter outside. So to identify this line, it's going to be line AB. So you're going to put that for that answer. My pen writes a lot bigger than what yours does, so I'm not going to have space to put all that Okay, so the line that's been identified in part A, sample problem 1A, is line AB. That's how we would name that. Now there are how many points that have been identified in part A? 4. A, B, C, and D. So we would just list those as A, comma, B, comma, C, comma, D, comma. So 4 points there. In terms of collinear, on the next part, they've drawn one line for us. So for that line, we want to know what 2 points are on that line, or how many points have been identified on that line, and only 2 have been, right? So for line AB, the only 2 points that we can say are collinear on that same line are points A and B. So you're just going to say A, comma, B. And then for the line that they've drawn, there are 2 points that are not on that. Those would be non-collinear. So what 2 points are not on that line? C and D. So we would identify those as just C and D. Okay, part B, we have a line segment, and we name that line segment using the endpoints. So this is just good review. It's segment KL. We put the bar above it. And then the only 2 points that are identified in this part B are points K and L. Part C, a little bit different. I want you to take a minute to see if you can come up with the answers for all of these on your own, and then we will go through them together. Now, this figure is not on the plane, okay? That is not on the plane, if that helps you out any. All right, for plane, we need, from our postulates before, we were shown, down below here, that through any non-collinear points, there's exactly one plane. So in order to identify the plane, we have to use 3 non-collinear points. Fortunately, there's only 3 points on that plane, so we would name it plane. Any order doesn't matter, SOT. So we would write plane SOT. Now, we have one ray identified on this figure in C. Challenge, what's that ray? IR. And I'm going to write it up here because I write bigger than what I have space. So we would write it like that. I is our initial point, or the beginning point of that ray. So, and it goes through R forever, so that's how we would name that. How many points have been identified in part C? 5. And so we would just list all those. S, comma, O, comma, T, comma, R, comma, I. Coplanar. For the plane that's drawn, what are the points on that plane, Madison? What are the points on the plane? S, O, and T. So we would just put that. And then there are some points that are not on that plane. Easton, what are 2 or 3? I and R. So we would just list those. Okay, so hopefully that gives you an understanding of what's on the plane, what's not on a plane, and just good review on naming things. So let's move to the next part of your paper. Okay, so now we're going to have, moving on to sample problem 2, we're going to look at that figure. And I need to let you know a few things about this figure because it's hard to, again, we're talking about a 3-dimensional. So right here, this line right there, that is like a pencil going through a sheet of paper. So the top part, S, is where it's going through the paper, and then the ray through D is above the paper. Where you see dotted lines, that's below the paper, under the paper. So this line that I've highlighted is actually a line that intersects goes through the plane. So you could imagine a pencil going through a piece of paper. Where that pencil is intersecting the paper, that's a point. Everything above here is above the point S. Everything below that piece of paper would be the dotted part. It's not on. So D to S, that is not on the plane. S is the only thing that's touching that plane. Hopefully that helps you out a little bit. What else do we need to talk about? Oh, remember, this is just the plane's name. It's not a point. Everything else would be that has letters on here are points. Okay, so the first thing we want to do is we want to identify the intersection of line QZ and segment WU. So here is line QZ. Let me use a different color because that's kind of blue. So there's my line QZ. And here is segment WU. So two lines or two line segments, if they're different lines or line segments, they're going to intersect in one point. Where do you see those two lines or line segments intersecting at? Point T. So we're just going to put point, why is it not doing that? T. There we go. Next one, we're going to find where pi, the plane, intersects with line DB. Oops. Okay, so we decided that the intersection of that line and the plane was point S. Then it asks for two the opposite rays at point T. So I got to figure out how to get back to this. Hold on. So using this, we're going to answer the question from this page. What is another name for plane pi? So three non-collinear points. Can you give me one point that looks like it's on the plane, Jenna? U. So she's saying U is on the plane, and she's correct. Catherine, what's another point that's on the plane? W is on the plane. Okay, so there's two, we need three, but these two are on the same line. So we need a third one that's not on the same line as those two, or the same line segment. So, Erica, what would you suggest? Q. So those are 3 points that are not on the same line. So we could say W, Q, U for plane, naming that plane. Okay, so we're going to move on to example B. Are we good? And let's talk about that figure because it's a little bit difficult to understand. So point L is on the plane. It's on that piece of paper. Okay, and that plane is called plane pi. We have two planes actually. We have plane pi, that's like the flat piece of paper, and then we have this plane I, that's like a vertical through that other plane. Okay, so we have two planes that are intersecting. And we have, let's see, point G is this point right there, point M is this point, and I believe point C is that point. Okay, and they're all on the same line, right? Okay, so make sure you understand that. Now, point S is right here. Point S is there, point B is there. So maybe you want to put a dot there so you know that that's point S. Maybe you want to put a dot there so that you know it's point B. And then what I'm going to want you to do here is I want you to try to answer these based on this picture. And then I want you to try to answer these based on that picture. And on this one we have two planes, I and pi again, that don't intersect. So they're like on two planes, like the ceiling and the floor. They aren't going to intersect. So based on that, try to answer those, and we'll go over those tomorrow. Okay, so that's what you have to have done by tomorrow. Good? All right. I'm going to stop my recording.